Okay, 22.1, solving equations by taking square roots. So we've evaluated square roots before when we looked at exponent representation, but a square root is nothing more than the following symbol. I'm going to move this down a little bit over here to the side. But a square root is this. Now really what that means, you don't see this when it's written, but there's a 2 there. That means whatever is under the square root, in this case we'll say x, can be written as x to the 1/2 power. And we looked at that back in Module 14 when we were looking at exponents and the properties of exponents. So what we're going to be doing is looking at how to solve quadratics by taking square roots. So what we've just finished is how to factor and find solutions, but sometimes they're not always exact answers. Sometimes they're what are known as irrational numbers or square roots that don't have exact square roots. So what we're going to look at is down here is how to take square roots of numbers and simplify. So for example, right here, square root of 49, that's an easy one. We know that's 7. But anytime you take the square root and solve, you always have this plus minus. It could be a positive 7 or a negative 7. The reason that is, there are two things that you can square to get 49. Positive 7 as well as negative 7. Same here with 25. It could be a positive 5 or it could be a negative 5. Either one. Then sometimes we have square roots that aren't exact. For example, 12. Well, what you do is you look for a perfect square that's in 12, a factor. So in this case, 4. 4 times 3. Why 4? Because we can take the square root of 4. Now all this does is it splits up. Square root of 4 times square root of 3. The square root of 4 is 2. So we have plus or minus 2. You cannot do the square root of 3. That's why it's an irrational number. But this is what we refer to as exact form. And exact just means it's in square root form. What about the square root of a fraction or a quotient? Well, you split it up. Square root of 16, oops, sorry about that. Square root of 16 over square root of 9. Well, the square root of 16 is 4, square root of 9 is 3, and again you have plus or minus. What about a decimal? Well, sometimes it's better to rewrite it as a fraction. So if you take 0.27, which is 27 hundredths, so you rewrite it as 27 over 100. Now we go back to what we just did right up here. With your fraction, you're going to split it up. Square root of 27 over square root of 100. Well, we can do square root of 100. That's 10. 27, however, you can't take the square root. It's an irrational number, so you look for a square that is a factor of 27, and that would be 9. 9 times 3. You split that up. Square root of 9 is 3. So then you have plus or minus 3 on the square root of 3 all over 10. And again, that's referred to as exact form. So that's how you simplify square roots, but then we also want to solve. So rather than go through the example, going back here are the your turn problems. So we're going to do one of these real quick. So let's do number 4. So just like solving, rather than factoring here, what we're going to do is we're going to try to isolate the x squared. So the way we're going to do that, we're going to subtract 6 from both sides, just like solving a normal equation. So we get 3x squared equals 27. And we're going to divide both sides by 3. And do that, we get x squared equals 9. Now, I want to get x, so the way to get just x is to get rid of the square, and the way I do that is by taking square root. They're inverse functions, just like back up here, the opposite of multiply is divide. That's how I get rid of it. So to get rid of a square, I take the square root. So whatever I do to one side, I have to do the other. Now, when solving an equation, one thing you need to remember is when you get x, you always have two answers, plus, minus. Square root of 9 is 3. That's our solution. So I want to give you a minute here. You can pause the video, try to do number 5, and then I'll work out number 5 and you can check your answer. Alright, so for number 5, add 9. Cancel, so we get 5x squared equals 11. Divide both sides by 5. And x squared equals 11 over 5. So now, just like in the other one, we take the square root. The difference is here, you can't take the square root of 11 or the square root of 5. So we end up with x is plus or minus square root of 11 over square root of 5. Now, one thing we're going to learn as we continue with this is you cannot have a square root in the denominator. So there's this thing called rationalizing. The way you rationalize a square root in the denominator is by multiplying the top and bottom by that square root. So what happens is when you multiply the bottom by square root of 5, it's like squaring it. So they're opposite or inverse relationship. So what we end up with is, on the top, if you do 11 times 5, we get square root of 55. On the bottom, we would get square root of 25 or just 5 because the square cancels the square root. And that would be our exact solution. Again, you cannot have a square root in a denominator. So now, we're going to change the form of the equation slightly. Again, you can look at your turn. So in this case, it says give the answer in radical form. So that all that means when you see radical form is put it as a square root, but it says also use a calculator to approximate the solution to do decimal places if necessary. But we're going to do exact answers. So what we're looking for is getting a square isolated. Well, in this case, problem number 8, our square is already isolated. So how do we get rid of the square? We take the square root. Now again, when we take the square root, we always end up with two answers, plus or minus square root of 64 is 8. Now, what this means is, again, I'm going to have two answers, but I've got to work out each part individually. So I take x minus 9 equals positive 8, but then I also have to take x minus 9 equals negative 8. And then I have to work each equation independently. So here I get x is 17, one solution, add 9 here. But because that was a negative 8, negative 8 plus 9 is 1. And that's my second solution. Now with problem 7, slightly different because of this 4. What am I doing with that 4? Well, I'm multiplying right there. So to get rid of it, I divide both sides by 4. The 4's cancel. I'll end up with x plus 10 squared equals 6. Now I have the square isolated. So now I take the square root of both sides. So on the left, the square and the square root are going to cancel and get x plus 10. On the right, you always get two solutions, plus or minus 6. Now I can't take the square root of 6. It's an irrational number, so I just leave it like that. I don't have to rationalize it because it's not in a denominator. But I still have to write what my final answer would be, which means getting my x by itself. So I have to subtract 10 from both sides. Now, because I don't have just a number on the right, I can't combine the 10 and the square root. They're not like terms, you could say. So what I end up with is negative 10 plus or minus square root of 6. Those are my two solutions. It would be negative 10 plus square root of 6, whatever that is as a decimal, negative 10 minus square root of 6. And again, you could graph these on the calculator, check on the calculator to see that the decimal you get for this radical answer matches the decimal you get on the calculator by graphing. The other thing they have is an example of a word problem. So I'm going to do that one real quick and then we will be done with this lesson. So it says a zookeeper is buying fencing to enclose a pen at the zoo. The pen is an isosceles right triangle. Okay, so let's draw that. That's a right triangle. Isosceles means two sides are the same. There's already a fence along the hypotenuse. Well, the hypotenuse is the side across from the right angle. So that's all fencing already. And it says which borders a path. The area of the pin, okay, so now we need area of a triangle. Well, if you don't know, area of a triangle is 1/2 base times height. Will be 4,500 square feet. The zookeeper can buy the fencing in whole feet only. Okay, that's important, because that means we're not going to put any kind of decimal answer. We're going to have to round. How many feet of fencing should he buy? Well, in this case, we are only buying fencing for those two sides. We already have the hypotenuse. So area we found in the problem was 4,500 equals 1/2 base. Well, here's the base, B. Well, I'm going to call it X. Times height. Here's the height. But what I know, since it's isosceles, is it's the same length, which is X. So what's X times X? That would be X squared. So I end up with 1/2 X squared. So how do I get rid of the 1/2? Divide by 1/2, or we talk about multiplying by the reciprocal. So multiply both sides by 2. So that's going to give me 9,000 equals X squared. Now to get rid of the square, I take the square root. And just like any other equation, typically you're going to have two answers here. Now, if you do square root of 9,000, that's not an exact number, okay? So you're going to round this decimal.